Okay, so last time we talked about what the odds ratio is. And we looked at the odds ratio as the change in the odds for a 1 unit increase in your x variable. So it's really pretty simple when we're talking about a binary x, because a binary x can only change from 0 to 1. So the odds ratio is just as comparing two sets of odds. Like if you're comparing males and females, it's just the ratio of their odds. So it's really sort of the simplest case, the easiest to interpret. Just try to get up. All right. So we're going to go back to that example where we're predicting whether somebody gets into med school based on their biological science score. But now let's add the, let's just look at just if there's a difference in the probability of somebody getting into med school if they're male or if they're female. Okay, so let's just have one binary predictor variable now, and it's just going to be the gender. All right, and we're doing a logistic regression, and we get this equation. Now, we get a linear equation in log odds. That's the log of p over 1 minus p, right? The natural log. So that's just given to us right here. Our fitting program fit the intercept and the gender slope. So we could say the predicted log odds, remember odds is just p over 1 minus p, the odds of getting in to medical school. I'll say put a little hat over it for the predicted log odds, is equal to what? Well, this is just given to you. Negative 0.2231 plus what? Plus 0.8109. That's our slope for this binary variable gender. So it's favoring one gender over the other because that's positive. Who's ever coded as 1 has a better chance of getting into medical school. So who's coded as 1? Females. All right. If we coded males as 1, then this would be the same exact magnitude. It would just have the opposite sign. So it would say the same exact thing, that men are less likely to get in by the same factor as women are more likely to get in. All right, so now that's the log odds. Then to get the odds, we'll just exponentiate this. And we get e to the minus 0.2231 plus 0.8109 times the gender. All right. So, and that's the same thing as writing what? You see, this is where our odds ratio comes in. It's the e to the slope because the odds change as a multiplicative factor. If we rewrite this as e to the negative 0.2231 times, right? Times e to the 0.8109 times either 1 or 0, depending. For females, it's 1. So their odds get, if you're a female, your odds get multiplied by e to that slope for gender. That says e, that says, okay. And this is the gender variable right there. And this part is the odds ratio. That's your odds ratio. Remember, we can just write that up at the top. So the odds ratio, we had it on the previous page, but we'll say, remember, the odds ratio is for gender, in this case, comparing females to males, is e to the slope for gender. So in this case, for gender, it would be that. Okay? Now, what is that? So in this case, it's e to the 0.8109, and let's get that. So e to the 0.8109. And it's 2.25. Okay? So what that's saying, the odds equation, see how it's this coefficient here, when you exponentiate that, that tells you the odds for gender. And since females were coded as 1, they have they're 2.2. The odds of getting to med school are what? Are this, e to the 0.8109, and that's 2.25 times what? Higher. Higher for females. If we coded it the other way, it would just be e to the minus 0.8109. The odds of getting into med school would be divided by 2.25 for males compared to females. All right, so what are the odds of getting to med school for males? Okay, so we're just going through the same, sorry if this seems very repetitive, it's just going through the same steps. So the odds what are the odds for males? Okay, so the odds for males are going to be what? You're just going to put a 0 in here. Maybe it's easier to see it this way. So we'll just, here's the two comparisons. And then, of course, this is just 0. I mean, this is 1. When you multiply here, it's going to be 1. Or if you put a 0 in here, same difference. It doesn't matter. So we'll say e to the 0.8109 times 0. So that's multiplying by 1. That's the odds for men. And that is 0.8. Okay? And if you do the same thing for women, what do you get? The odds for females is just going to be, this part's exactly the same, right? And then you're going to multiply by e to the slope, which is the same thing as 0.8 times what? E to the 0.809 is times 2.25, and that's 1.8. Okay? And their odds ratio is just the ratio of those two odds. I'm just saying the same thing over and over again here. Sorry. I don't know why I wrote it so many times. Okay. So this is really easy for a binary variable. Because why is it so easy? It's just a change for a 1 unit increase in x. So here, a 1 unit increase in x means changing from x equals 0 to 1. If x is gender. Yeah. So it's pretty simple. In your homework, you did something more complicated because you had quantitative variables. And you didn't multiply just by e to the slope. You multiplied by that, like if there was, I think you were looking at a 2 or 3 point difference, you'd have to multiply by it over, e, if it was e to the slope times e to the slope, however many units in x you increased by. All right, so let's just, one thing that we can look at is we can do this same odds ratio, look at it as in a simple 2-by-2 table. So back in Stat 100, we looked at chi-square independence tests, and probably you had that in AP Stats. I'm not going to go over that here, but if you want to, I can explain the simple what's happening here. So let's do the same problem using a chi-square test for independence. Is gender, is whether you're male or female, does that tell you independent of acceptance to med school? Does it, if knowing somebody's female, does that make it more, does that change the odds of them getting in? Hey, let's look at this for a minute. Was it significant? We haven't looked at these how these are computed or what's going on here yet. We're going to look at that later. But here, the p-values are given, and it looks like gender isn't significant. It's 14.24. And when you just do a chi-square test and we got a p-value of 13.83. If we did a chi-square test for independence, we get it's slightly different. It's a slightly different values, but they're, with large samples, they'd be the same. Okay, so is gender independent of acceptance to medical school? Look at the output below. Notice how we get just about the same chi-square statistic as we did using logistic regression. They're not exactly the same because logistic regression uses the maximum likelihood estimation, and we're going to look at that later. Okay, in our inference chapter. So now, looking at this, can we compute the odds? We can do the same thing here. It's very easy. Which we focus on. All right, so there are 55 total med school applicants, and 27 of them are male. 12 of those got in, and 15 didn't, and 28 are women. 18 of those got in, and 10 didn't. All right, so compute the odds for females. Do you remember what odds is? It's p over 1 minus p, but you can think of it as the number of it's the number of successes, like ones, we could code it over the number of failures, right? That's the same thing. Okay, so if we do this for females, what is it? How many successes, this is coded a success, we could say is a 1, getting into med school, whatever's coded as 1, over 10. So that's 1.8, which is exactly the same thing we got here. If you did it this way, it's the same thing. What is it? It's probability. You could say 18 over what? There's total number would be 28. So it would be 18 divided by 28 over 10 divided by 28, which is the same thing. This is just easier to do it that way. All right, so now compute the odds for males. You can do that, right? What's it for males? The odds for males would be what over what? Just write it down in your paper. Make sure odds for males. It's really easy to do it this way. Make sure you get the same thing. It's 12 over 15, which is 0.8, which is exactly what we got on the previous page. So it's super easy to translate this to check your answers and make sure just setting up a little table like this. And the odds ratio, well, the odds ratio is just going to be, because we coded females as 1, we'll just say the female odds over the male odds, which is equal to 1.8 over 0.8, which is 2.25. And there's e to the slope. It's the same thing we got before. And how does it compare? It's the same. Probably a lot of you have seen, I don't know if you've been in other, this odds ratio is very commonly used in biostats, a lot of different statistics classes. I don't know if you've seen it before, and often we'll teach it to you as in a 2x2 table to say AD minus BC. Well, that's really the same thing. They'll say, if you've learned it that way, note, I'll just say this because some of you probably learned that. In 2x2 table, and we can just make the table like, we'll just do the same table. We have like a 0, 1, male and female, right? And then we have a 0, 1, no and yes. Up here. No and yes. Just put 0 and 1, no and yes. Okay. And we just have 4 numbers in here. Let's call them A, B, oh, how do they write this? A, B, C, and D, right? Yeah, that's it. And they said, you're told that the odds ratio is equal to AD over BC. You're just told that. This times this, but you know why it's true? It's just because it's what? The way we figured it out was what? if this is what we'd say, the odds same as the odds, probability of success over the probability of failure, that's B over A. Is this right? Oh, I have to do, because females are 1, I'd have to do D over C, because they're coded as 1, over B over A, and that's the same thing, which is equal to AD over BC. What? Did I do something? Did I do something? I'm just saying, look, I'm just saying 18 over 10 divided by 12 over 15. So just D over C. It's just if you're taught this stupid, I shouldn't say stupid way, but sometimes people are just taught to do things without understanding them. They tell you to do this. So I just want to, if you were taught that way, I just want to show you it's the same thing, or if you run across that. I kind of hate when people give these rules and they just say, okay, do this and that. When it's just, you know, your successes over your failures, D over C, because you coded it that. I think it's so much easier to just know what you're doing. But if you're taught this, it's the same thing. So don't worry about it. Does that make sense? I didn't hear your question.
I was just wondering why we didn't convert it to probabilities.
Why we didn't convert it to probabilities, we did right here. It's because the probabilities are going to cancel out. Because the question is, why don't we do P over 1 minus P? Well, it's really the same thing, because success out of failure, it's success out of the total outcomes over failure over the total outcomes would be P over 1 minus P. And since the total outcomes are the same. Does that make sense? Good question. Yeah, P over 1 minus P is the same thing. Because as success over failure, because the total's the same. Does that help people? Ask another question, anybody? And don't even think about this unless, I'm just doing this because people have asked me, oh, is this the same thing, and why is it the same thing? So, all right, don't worry about that at all. Any questions on this? All right, so do you think I was kind of curious about this question. Do you think that there's gender discrimination in med school acceptance? Interesting question. It looks like maybe females are getting favored. Maybe they are. Maybe it's some kind of reverse. It used to be back in the day where males were highly favored. But maybe now females are being favored for some reason. I don't know. We don't have enough data. But why don't we combine it? Let's do multiple logistic regression and say, I mean, we can't tell. Maybe females are getting in, more likely to get in, because maybe they have higher biological science scores. So maybe if we controlled for that, it would disappear. Maybe it's really that they are better. You know, there's lots of things. We want to see if there's some confounder. Is it really that females are being better? Well, what if females are doing better on everything? That wouldn't be discrimination. So the strongest predictor was the biological science score, and we already looked at that. So let's control for that and see if the gender slope disappears. I mean, remember, it's not significant. Maybe it will just disappear completely. So that's what I did. And I said the process of going, and now this is going to be so easy for you guys, because the process of going from simple logistic regression to multiple is almost exactly like it was in regular regression. So this step to go to multiple logistic regression is a no-brainer for you, because you've done the same thing with regular regression. It'll just be really easy for you. Watch. The coefficients in the multiple regression are generally different from the coefficients in the simple regression because, as usual, they indicate the change in the outcome controlling for the other variable, i.e., assuming the other variables are held fixed. So if I was interested in whether females are favored, and I thought it might be they just have higher scores, then I could put those score, whatever I think might be the difference, that they're not, it's not them being female, it just might be that they're better. So then you would want to put in everything that you think they might be better on and then see if it still holds up. Does this make sense? All right, so that's what I did. I really thought when I originally did this that males, if anything, would be favored. So that's how I went about this. And I said, let's consider a multiple logistic regression model by including both the science score and the gender in our model. So that's what we did, all right? And it's not only so that it will make more accurate predictions, that's what I write here, but my real motivation for doing this was to also control for the confounder. So we should probably put that in here. Where can I say that? And you could also do it to control for a possible confounder. Because what it's going to do is say if they, for males and females who have the same exact biological scores, is females still favored? All right, so they're going to change these slopes. And here's the output. So I was really curious to get this. So we're looking right here at our slopes. And we get negative, so this is the log odds equation, negative 17 plus, look at this, the gender went up, not down, it went up. And of course, this is positive 2, 1.66. This says, how does that change? Look, first of all, we got more significance. We're significant now, it's less than 5%. So we got a bigger effect, which probably means, if anything, that women are doing worse on the biological science score, and still, but it was, the gender effect was strong enough that it showed up even when we didn't include this. But there might be other confounders, so we shouldn't stop there. What did we get previously? So we only got a slope for gender here of 0.809, and when we did the biological ones separately last time, wasn't that right here? We had a smaller slope of 1.276, so they both got stronger. All right, and we have significance, very strong, very clear significance here for both variables. All right, so now here's our model. So now how are we going to interpret this? So, so let's think about it. Look at the equation, okay? Anybody have a question? Okay. So look at the equation. Who has the better chance of getting into med school, males or females? So all you have to do is look at this, right? And you know it's females because it's positive and females are coded as 1. So it says as you change from 0 to 1, your log odds go up, which means your odds go up and your probability of getting in goes up. All right? So females, because it's a positive slope. And females are coded as 1. If we happen to code females as 0, that would be a negative slope. And then we'd say, we'd come up with the same conclusion, that males have less of a chance of getting in. All right, what are the odds ratio for gender and what does it mean? So, so what's the odds ratio? So remember the odds ratio, I'll just write the odds ratio is when you exponentiate this, right? Exponentiate this, you'll get, this slope, this factor is going to be the multiplicative e to the slope, and it's for the gender. I'll just put a G for gender. So let's just see what that is. It's going to be stronger. Before it was 2.25 for gender, but now look at this coefficient, it's really changed. So now it's going to be e to the 2.05, right? That's the odds ratio, which is 7.5, much stronger. So what does that mean? So let's just make sure you know what it means. So it means that the odds of getting into med school, I thought this was really interesting. I'd really like to explore this further with more of a data set, but it's hard to get data on this. It means that odds of acceptance is, what do you think? I'm just going to put a blank here, times, oh, like it would be exam, for females than for males, given what? that they have the same, so you'd compare male and female have the same biological science score. So given the same scores, biological science scores. And since I said females, then for males, this is going to be, it's higher by a factor of 7.5. If I asked for males, then it would have been 7.5 times lower. You divide by 7.5. The coefficient would be, it's just the same thing. All right, so what's the odds ratio for biological score, and what does that mean? All right, so now we have a quantitative variable. We're still going to do e to the slope, but now it's e to the slope for the biological science score. I'll put that down so you know. So it's e to the what? 1.66. That's what that is. And so this, what does this mean? Well, now that means as you change 1 point higher, as you go 1 point higher in your biological scores, then your odds of getting into medical school increase by that amount. And that is not quite as strong an effect, but it's 5.26. All right, so we can do the same thing. So it means, just so you get used to these odds ratio, it's confusing sometimes. Log odds, I just want you to get a feel for what it means. So it means that the odds of acceptance are what? Okay, the odds of acceptance are, now you're going to have 5.26 times higher if you go up 1 point in your biological science score for each 1 point increase. Okay? In your biological science score. So it says, and of course it would be what? If it was a decrease, it would be 5.26 times lower. So you would divide by 5.26. Oh, most important point. Given what? Given what? That you're comparing the same gender. So if you're comparing males to males, this is the factor. But what if you're combining both of them? Then we'd have to combine both factors. So if you just look at this, if you're comparing a male and a female, the female has a 7.5 times advantage, which outweighs the 1 point here. So, but if it was 2 points, then whoever's got the if a male got 2 points higher, he'd have a better chance of getting in. But for a 1 point difference, this is a stronger effect. So we can look at that. Let's do that. We can do some of those. We can just do a few of these, and then you can let's see. Boy, I might let you out really early. How many people haven't voted yet? And it would help, right? It's a rainy day. You need to vote. I think I am going to let people out early. Maybe we'll just finish this page because we have, you know why? Why don't we just finish this page? You can do the homework. It's about toilet paper. It's like fun. It's like you're going to predict whether males or females. We're more likely to, you're going to look at that. Like, look, you know, just what we did today, but like who's more likely to water fold their toilet paper? With the data, with the survey data? You can guess. Do you think it's males or females? You can guess ahead of time. I actually did it before. I wrote that before I looked at your data, so you can investigate your data, which is posted now, and you can look at the same stuff and see if it held up in your class, whichever direction you think it went in. Let's do this, and so then you can leave and you can go vote. Okay, is that okay? I'll stick around for the full time. If anybody wants help with the homework's posted, you could do it, and I can stick around. But it's election day, and I just want you to go out there. And this might be your first election, some of you. I want you to have a chance, and it's raining. So let's hurry. Not hurry, but there's not much to do here. Okay, so now we're going to use this equation to fill out this table. First, if we just compare a male and a female, right? A male and a female who have the same biological science score, what is going to change here, right? Well, we just said, okay, so if you take it step by step, if you wanted to, look what happens. Say you put 10 if you have a male, this part is 0, right? Because you put 0 in for gender. Remember? So when you're comparing these two, everything's going to be the same except what? We're going to have this part will be the same. We'll just have negative 0.4, what we already got here, plus what? 2.015, right? Isn't that true? You see what I'm doing? I'm just putting a 1 in there. Does that make sense to people? I just want to show you where the e to the slope. We know that the odds are going to change. Remember, we just did it. E to the slope is what? So let's remember these. Okay? So we have, remember the odds for, so we're going to multiply by e to the slope. The odds ratio. Okay, so e to the, just let's write it up down here. That's equal to 7.5. That was for gender. And then we have e to the 1.66. That was the odds ratio for biological, is 5.26. So if you just, so I just want to show you how that plays out. So here, when you're going to exponentiate that, you're going to get e to the negative 0.4 times e to the 2.015, but that's the same thing as, so it's just going to be whatever we got there, 0.676 times 7.5. Okay, I just want to show you where this plays in, just right there. So you could have, knowing this, you can just say, okay, 0.67 times 7.5, and I got 5.025. So how would that change the probability? What would that be? The probability for a female with the same biological science score of 10 would be what? 0.5025. Probability is equal to odds over 1 plus odds. Remember that? So that would be, look what I just did. 5.025 divided by what? 6.025, right? And so when I did that, I didn't do it. Darn, I'll do it right now. So I get 83.4%. So instead of 40% here, it's 83.4%. You can just round to 83. Okay, 83.4. So it went from 40% to 83%. What if a male just goes up one? How would that change things? If a male just goes up 1 here, what would change? He would go from negative 17 plus, instead of 1.66 times 10, he'd have plus 1.66 times what? Hello? Is this too slow and boring for you? Times what? 11, right? So that would be the same thing, right? That's the same as, that's equal to, here we got negative 0.4. All I'm doing is adding 1.66, right? So when I exponentiate it, I get e to the negative 0.4 times e to the 1.66, or 0.67 times 5.26, whatever that is. I'll just do it that way. So we get, you know, if you want it to be more exact, this has a lot of rounding, but I want you to see where it comes to play, that's all. Where this e to the slope comes to play, the odds ratio right here. So I'd say it would change by whatever I got before, 0.67 times 5.26, and I got that. That would be the odds. And then I'd divide it by what? 1 plus that, right? And it changes from 40% all the way up to, I'm just going to round here, but when you're doing this, you should leave all the numbers in your calculator. Okay, so here I'm going to say what? what did I get here? I can't even read it. 3.52 over 4.52, and that is 0.78. A 78% chance he goes up. But you see, just being female increased the chances more. All right, now we can finally do what happens if we were going to divide. Well, if we were going to go down a point, well, you could see what happens right here. You'd say, okay, it would be negative 0.4. You'd go down by negative minus 1.66. And when you exponentiate it, that's the same as dividing, right? Dividing, multiplying by. All right? So it would be the same as taking that 0.67, and now we're going to divide by 5.26 instead of multiply, because you went down a point. So let's do that. So we'll have 0.67 divided by 5.26, and there we get, that's 0.127, and then we're just going to divide that by what? To get the probability, we're going to divide it by 1 plus that. And we get 11.29%. All right, I'm just rounding everything here, but I think you understand. Any questions so far? All right, so now that you sort of worked out some problems there, let's just think about this. A female has a biological score, 2 points female. So she's going to have an advantage by what? By how much for her odds? 7.5. Has a biological score 2 points lower than a male. How's that going to factor in? We know if she has 1 point lower, because here's our equation. This is bigger than this. So if she has 1 point lower, she'll still have an advantage. But when you have 2 points lower, she'll lose that. And you can see why. So we're comparing the odds of the female. The odds for being a female, just think of it this way. The odds for being a female is this advantage, 2, right? But then she has a disadvantage, so we're going to divide by, because she went down 2 points. So it's e to the 1.66 times e to the 1.66. It's the same thing as writing it this way. E to the 2.015, maybe you can see it better this way, minus 2 times 1.66.
Can you push it up a little?
Oh, yeah, sure. 2 times, see, it's just doing that. That's the same thing. So you can see when these two things are equal, they'll have equal odds. When this is equal to, this is equal to something times that. Right now, this is going to be negative. It's lower, and so her odds are less, it's less than 1. So that means now she has lower odds. So the odds of female getting in are only 0.27. They're not 1 times. If they have equal odds, they're 1. Let's see this one. The odds of getting in, does everybody understand this? Just think of this. She has an advantage for being female. Because she's lower, you have to divide by this. And if she was lower by 3 points, you'd just divide by another one. If she was higher by 3 points, you'd multiply by those. Does this make sense? So you can just look at these coefficients here. She gets this. You can go up here. She gets it for being female. If it was a male, we wouldn't. He gets it for being female. And then this is either you just multiply up here by the difference in the biological scores. If it's 3 points higher or 3 points lower, it would be negative. All right, let's do this one. So the odds of female getting into med school are the same. So when are they going to be the same? They're going to be the same as we saw when whatever number in here makes this 1, right? When this is, well, we can just do it slowly. All right, so the odds. Remember what the odds are. The odds are going to be for, if you want to start with odds, you could say the odds are, I think it's easier just to go to the log odds equation. But if you wanted me to start with the odds, I'd do, okay, the odds for female are this plus 2.015 times 1 for being female. I'm just exponentiating that. Plus 1.66 times whatever biological score she gets. So I'll put a little female there. I want that to be the same as for men. So what are their odds? So their odds are just going to be the same, except you'll have a 0 in there, right? So it's negative 17 plus, that's 0, plus 1.66 times what? Times the biological score for males. That part. All right? And now, of course, I could anti-log both sides. I didn't really have to do that. First of all, those are both the same. And so I get 2.015 plus 1.66 times the biological score for the female. I'll put it down there. Equals 1.66 times the biological score for the male. All right? So when those two things are equal, right? So we can simplify that and get 2.015 is equal to, just subtract that from both sides, is equal to 1.66 times the biological score for the male minus the biological score for the female. And that's what we saw right here. We saw this coefficient right here has to be 2.015 divided by, you want to make this right here to equal 0. This, 2 is too big to make it equal, 1's too small. So that's what we did here. And that's when the difference in their scores is that. So when the difference in their score is 1.214. When males score higher by that factor, of course, you can't get that factor exactly, but that's about where they'd be equal odds. So that's being, you can think of it as being female is equivalent to a male, your odds, if you're a guy, and you score 1.214 times higher, you'll have the same odds of getting in. Everything else being equal so far. We should add more possible confounders. This is really interesting. You can see why it's fun to do this kind of thing. And I don't like to see this discrimination either way, So I was surprised. I figured it was discrimination against women, but it might not be. It might be discrimination against men. I think it's important to look at data and try to figure it out. Of course, we don't have the full data. All right. Anyways, so this is it for now, and you can do your homework. Enjoy doing it. You'll solve the important question about who's more likely to water fold their toilet paper, males or females. And next time we meet, we're going to have a new president.